This is Mr. Martin. These are video notes for Geometry Advanced, section 12.4. We're talking about law of cosines. This is a second example for you. This is on page 18 in your notes, or it should be around there. So I'm given three sides of the triangle, and I want to find the three missing angles. So as always, I like to start with a triangle. And I usually will just draw the same generic triangle. So here's A and B and C. And then side A is opposite angle A, so that's going to be 4. And side B is opposite angle B, that's 5. And my remaining side is 7. And then I'll go ahead and write my answer chart here. I've got A, B, and C. And then side A was 4. Side B was 5, and side C was 7. And again, this is required to put anytime you're using law of sines or cosines in solving a triangle. So the first thing you'll notice here is that I don't have any side and angle that match. I don't have angle A inside A or angle B inside B. So what that tells us is that we cannot use law of sines, because in order to use law of sines you need to have an angle and the side that goes with it. So since I can't use law of sines, I need to use law of cosines. And since I'm looking for the three angles, I'm going to start with one of the angle formulas. Now, really I could start with any of these, but what I normally like to do is start with the largest angle. So angle C is going to be the largest angle because it's opposite the longest side. So my formula is cosine of angle C is equal to a squared plus b squared minus c squared over 2ab. Let's go ahead and substitute everything in. I've got 4 squared plus 5 squared minus 7 squared over 2 times 4 times 5. And that gives me negative 0.2. And again, this doesn't give me what C is, it gives me what the cosine of C is. So in order to find C, I need to do the cosine inverse of the answer that I got in the previous step. So that's cosine inverse of negative 0.2. And that should give me 101.53 degrees. So that's angle C, 101.53 degrees. Okay. At this point, I have an angle and a side that go with each other, so I can use law of sines, or I could go ahead and use law of cosines again. So feel free to pause the video if you want, and if you want to try and use law of cosines again to find one of the other angles, go ahead. I'm going to use law of sines just to show you that we can do it. So what I'm going to do is I'm going to find the next largest angle, so that's going to be opposite the next longest side, so I'm going to find angle B. So I know that the sine of B over side B, which was 5, is going to equal to the sine of C, so that's 101.53 degrees, over, don't forget to have sine with your angles, over side C, which is 7. Okay, sine of B over B is equal to sine of C over C. Alright, and then if you take my advice and put what you're solving always in the numerator, then you only have to cross multiply one way. So I'm going to get the sine of B is equal to 5 sine 101.53 divided by 7. Again, notice how I put the 5 in front. And this is more important even when you're plugging it into your calculator, so you don't take the sine of 101 times 5. You just want 5 times the sine of that angle. And that's going to give us about 0.6999. And then that's the sine of B, but we want angle B. So we have to take the sine inverse of that number, 0.6999. And that should give us about 44.42. So now we have that. So if you use the law of cosines to find angle B, make sure you got the same answer. And now that I have these two angles, I have to just subtract those from 180 to get the third angle. So 180 minus 44.42 plus 101.53, and that should give us 34.05. Alright, and there you have the three missing angles. We used a variety of methods. Again, if you have any questions, make sure that you ask in class. Not extremely difficult material, but you will need a fair amount of practice so that you can get proficient in solving these types of problems. Alright, we'll see you next time.